Once we have center and corner markings, we can use that as part of our logic to make progress on a puzzle. We'll start by looking at some of the implications of the center markings. Let's say that we have two cells in the same box with the same 2-digit center marking. What does this mean? We may not know which cell is a 7 and which cell is a 9, but we do know that the 7 and the 9 are restricted to just those two cells in this box. To see why, let's suppose for a moment that we know row 5 column 4 was a 7. Then if we follow the logic of center markings, we would get that both of these center marked cells would be a 9, and that would violate the rules. And the same thing would be true if we deduced that row 5 column 4 is a 9. And this logic holds for all the unmarked cells. Another way of saying this is that the solution to the puzzle can only have two possibilities for these cells. Either this one is a 7 and the other is a 9, or it's the other way around. This configuration is called a pair, or sometimes a naked pair, and the logic of pairs is not limited to boxes. Suppose we have the same 2-digit center marking in two places in the same row. The exact same logic would prevent either of these digits from appearing in any other position in that row, and we could do the same thing with the columns. A similar logic can be applied to get triples. If you see the same 3 digits in 3 cells that all see each other, you know that those 3 values are locked into those 3 cells. Here's another example. You will notice that the markings are not identical, but this is still a triple. Each of these center markings is a subset of the digits 3, 5, and 9. This may feel confusing at first, but a good way to think about it is that a 5-9 center marking is just a 3-5-9 center marking that has been restricted a little bit further. All you need is that you have 3 digits constrained within 3 cells, and then you can know that those digits cannot appear anywhere else in the corresponding region. Pairs and triples give us another way to eliminate possibilities in cells. Here's an example. Pause the video and take a moment to see if you can determine a digit. Hopefully, you've started to pick up on the pattern of thinking about rows, columns, and boxes. In row 3, we have a 4-8 pair. In column 8, we have a 1-2-7 triple. And this pushes us to think about the cell that is in the intersection. We already have 5 digits that we could eliminate as possibilities. And if we look inside box 3, there's a 5-9 pair and a 6, which eliminates 3 more possibilities. This means that the digit in row 3, column 8 must be a 3. This way of thinking is just an extension of eliminating by value. The only difference is that we are eliminating values in groups instead of individual digits.